Hi, and welcome to this presentation on Heath Data Dictionaries. My name is Eric Brown, and I'd like in this session to highlight some important shortcomings with the use of coded data in data dictionaries, particularly as we adopt more streamlined electronic collection methods. In many countries, there is a move to improve the quality and utility of clinical data sets, such as through the establishment of clinical registries, which can be used both by researchers and administrators. As we move to a world where data is collected electronically as part of the clinical process, we need appropriate specifications for our data that can ensure safety, quality, implementability, utility, and maintainability. But we don't want to forever be battling with the proliferation of unnecessary and ad hoc codes. Let's first look at the background to the use of codes in data dictionaries. Back in the dark ages of paper collections, there were some sound reasons for using codes. They helped to reduce the burden of transcribing from case notes to data collection forms. In the early days of computers, when memory was tiny, when processing power poor, and when text processing software was quite rudimentary, computers could actually handle codes more readily. They had trouble dealing with large quantities of text. But by the 1990s, we had well-established innovations for handling text data. We had the World Wide Web, XML, platform-independent programming environments, Java, almost ubiquitous networking, graphical user interfaces, pop-up menus. And by now we have a large capacity storage capability. We have fast network links, new web technologies, podcasts, streaming video, object databases, XML databases, and a host of other IT innovations. But still, we have the same tired old approach to defining health data sets. It's time to dissolve the pain wrought by those codes and move into the 21st century. All we usually need for a given data element is a set of prescribed values, bereft of any arbitrary codes, often just the text that the clinician and the researcher understands. No more, no less. Possibly no other area of healthcare activity has been so shackled by the protocols of last century. A few years ago, the American Health Information Management Association published some guidelines for developing a data dictionary. In those guidelines, they cited a large enterprise that had discovered that they were using some 40 different ways just to capture yes and no. The guidelines recommended that such conflicting representations be standardized to just one set of values for the enterprise data dictionary. But they failed to even discuss what might be the best set to adopt. What is wrong with the values yes and no? Simple but effective. In this slide, I wish to highlight the effect of changing just the codes for yes and no throughout an enterprise, as suggested on the previous slide. It is often impractical in distributed environments to ensure that all contributing systems will be reconfigured at the same time. So here we have an example where System A will be altered, but those changes have yet to occur to System B. So the clinician in System A says no. The no is translated into a zero, a code 0, sent to System B and rightly interpreted as a no. After the change has been made to System A, the no is sent, but this time it's sent as a 1, code 1, and is received incorrectly by System B. In this example, the value set has been updated to reflect a new laparoscopic procedure, leading to a republished code set. So before the republished code set has been promulgated, clinician selects hysterectomy. That is reported as code 25 and received by System B correctly as a hysterectomy. After the change has been made to System A, this time hysterectomy has been replaced by code 26. And this ends up in System B, which is yet to be changed, as an incorrect value. You might think this wouldn't occur in real life, but I'm sure it does. Now let's consider a data repository collecting data over a number of years and whether code sets have changed over time. Here we have 3 different years' worth of data, and those code sets may have been changed during that period. They may have been changed several times. But for each of these data sets, the meaning must be checked against the corresponding data dictionary used by the supplier at the time the data was supplied. In a distributed environment, that is a quality nightmare. Not only is this a quality issue, the same dictionaries would also have to be available to each and every researcher who needs to interpret the data and be integrated into their analysis software. If the meaning, that is to say just the text, had been stored instead of the code, then this would not be a problem. So what are the requirements for codes? Why do we need them at all? They're not needed for human interfaces these days. We've got keyboard completion, pull-down pop-up menus, voice activation. They're not needed for display, nor for statistics. They're not needed for data exchange, not needed for data storage anymore, and they're certainly not needed for querying data stores. They just make life more complex than it otherwise needs be. There are, however, some legitimate uses of codes where they work behind the scenes for computer processing benefits. One example is the clinical controlled terminology SNOMED. Here the codes are used to support the complex hierarchies, synonyms, the interrelationships between different concepts, terminological expressions, the versioning of terms, language translations, subsetting the terminology. SNOMED is such a large terminology that in some instances you want to constrain down the allowed set, and the codes help in that process. Similarly with detailed clinical models or information models, such as the open-air archetypes. Here again, codes are used behind the scenes for efficient EHR querying, for, again, language translation, for cross-referencing, for binding the information structures to the terminologies. But the codes are hidden from users. Also, in order to make use of these new innovations, we still need stronger governance, better distribution mechanisms, and better version management in those supporting those distribution mechanisms. Another place where codes can add some value is where human interfaces need to deal with complex concepts which are too hard to describe textually. ICD-10AM is the classic example of this, where a code replaces a concept which is otherwise too hard to describe. The codes are designed for highly trained specialist coders, and the code is actually an aide-memoire to the coder. Furthermore, the codes need to be interpreted correctly by the downstream users, and that is not always easy to do without access to all the rules and the principles under which the codes were developed and need to be interpreted. So where to from here? Well, if the data sets are to be gathered by clinical systems rather than manually transcribed by humans, then a new approach totally should be adopted. We need to consider the effects of changes to the data dictionary over time, what the changes mean to implementations, how they're going to be controlled. We need to become aware of the emerging e-health approaches, such as controlled terminology, SNOMED and the ilk, and open-air archetypes. But above all, keep things simple. Simple to use, simple to implement, simple to test, simple to change. Instead of codes, just standardise the appropriate set of text values for each data element. This will contribute significantly to those key parameters of safety, quality, implementability, usability, maintainability. This presentation has only touched on a few issues to do with codes and data dictionaries. Thanks for your time, and I hope you found this presentation useful.